Okay, a request was made to go over a heat and temperature problem. And if you're tuning in at a later time, it says how much heat energy, or it doesn't say that, but that's what we're referring to, is needed to raise the temperature of aluminum that has a 27 gram sample from 410 degrees centigrade to 3100 degrees centigrade. Why are these two numbers important to what we see over here? Right, because this has to start below the melting point and end past aluminum's boiling point, which it does. So, C subscript P, do we remember what that means? That is your specific heat. So, it doesn't quite say that in here, but from a process of elimination later, this must be for liquid aluminum. Okay, so the specific heat for liquid aluminum, 0.9025 joules per gram degree centigrade. The heat of fusion is 10.71 kilojoules per mole, and the heat of vaporization is 291 kilojoules per mole. The specific heat of gaseous aluminum is 0.385 joules per gram degree centigrade, and the specific heat of solid aluminum is 0.418 joules per gram degree centigrade. Now, what is the problem with these two numbers and or variables? Right, because everything else is measured in degrees centigrade, it's measured in grams, and it's measured in joules and not kilojoules. Okay? So, we'll go ahead and pick this one. When you said multiply by 1,000, you're not wrong. 10.71. Okay, kilojoules. Okay, so do you want to get rid of your joules first or your mole first? Mole. Okay, so that means since this is a known substance, how do we get rid of this mole in our next step? Okay. So for every mole of aluminum, how many grams do you get? 27 grams. Okay. Now, it's just a coincidence that we started with 27 because that's what was requested. Well, that's what I was going for. So then these have canceled. Now, we're in kilojoules per gram, so we're pretty close. But notice we need to get it into joules per gram. So how do we get rid of this kilojoule? Multiply by 1,000. Yes, you're going to multiply by 1,000. If you wanted to illustrate it, this is what you're doing. Now we've got joules on top, grams on the bottom, and that's what we're looking for. Okay, so 10,710, if you like skipping a step rather than writing that out. Because when you multiply this by 1,000, you're just moving the decimal place to the right 3 times. 396.67. Okay, so we can do this heat of fusion. So we'll do the heat of vaporization next. 291,000 divided by 27. That gives you 10,777. Okay, now we have both of these in joules per gram. So now we can proceed. It's just that in every step, you have to multiply your mass times your specific heat of, no, we need solid first, okay, because we got to melt it. Okay, that's where your Q1, Q2, Q3, Q4, Q5. Okay, so we'll just do this. We got 27 times, I'm going to run out of space if I keep going that pace. Neither one. Okay, so then what's our specific heat for solid? Looks like 0.418. Okay? And then we need a temperature range.
Oh, I know that.
410.
Okay, so 660 minus 410, 250.
It's gotta be given to you, right?
Yes, you would have to have the melting point and boiling point.
Yeah, that's right.
Then we got 27 times the conversion we made, which is 396.67. Okay. Then in Q3, you have 27 times, looks like 0.9025.
Softball girls. You girls need to go.
And then where does our temperature range occur for step 3?
660 to 2000.
That's the liquid point, right?
2000.
Close.
For step 3?
It may be, but in step 3, how do we get a change in temperature like we did here?
Your melting minus your boiling.
That's correct. You have to take your melting point, subtract it from your boiling point, so 2517 minus 660, and it probably is what you had mentioned, so that's 1857. That gives you Q3 now. Q4, 27 times the conversion we made, and then finally in your last step, it's 27 times 0.385. Then our last temperature change, we have to subtract 3100 and 2517 from 3100. That gives you 583. That's your last temperature change. Okay? We went over that fairly quick. That's why we have this recorded. And
Heat diffusion always 334?
It depends on the
Or is that
element.
just
depends on the substance. Now you're talking about water.
Yeah, that's what I was meaning.
Okay?
Find that in the packet.
That's correct.
2.06?
2.06, I believe, is the specific heat for ice, solid water. Right. Okay.
What about the specific heat for liquid?
That would be 4.18 for water.
184.
184, okay?
This guy's really smart.
Mm-hmm.
Why am I in
Gas
that
is
tree?
about
2.02, that's right.
Golly, this guy.
And then 2260 is your other given.
I think the girls actually gotta get going
That's your
now.
HV.
Why do you want to get rid of them so
Because they said they
efficient?
wanna leave, but they've been sitting there.
Well, I don't know. It doesn't start till 3 o'clock. I don't think they need to be on the road yet.
That's what I'm saying, but they say it takes an hour to warm up.
Takes an hour to get there, I guess.
Yeah.
But, you know.
What day?
So work on these. A lot of you have figured out, yes, it is the idea of as long as you keep working hard, good things are probably going to happen. Okay? So it's where in a couple weeks from now, you have to do a self-reflection and say, I did the best I could, or
No.
there is room for improvement.
Always room for improvement.
There's always room for
If you
improvement.
say
That's-
there's no room for improvement, you're lying to
Your classmates can't answer that. Only yourself can do
No,
that.
I'm talking like everywhere. This
How would
world
you
just
weigh
needs
blood
some
pressure?
improvement.
Joules.
We need smarter scientists out there in the world.
Yeah, would not hurt. So, I believe it is we are winding down on time. So, come with questions, and we're happy to point you in the right direction. Catch up to you next time.